Polynomial inequalities. Let's first consider what graphing polynomial functions will reveal. Consider the function f of x, which is equal to x cubed minus 13x squared plus 44x minus 32. Use the fact that x minus 4 is a factor in order to factor the polynomial. And after we're done factoring, we're going to identify the x-intercepts of the graph. And then we can answer the question, at which x values does the function value change from negative to positive or from positive to negative? Let's start with part A. Use the fact that x minus 4 is a factor in order to factor the polynomial. Now we can do this with either long or synthetic division. Since synthetic division is slightly faster, I'm going to set it up that way. Now the factor x minus 4 also tells us that the 0 that corresponds to it is positive 4. And then if we write down the coefficients of our original polynomial, 1, negative 13, 44, and negative 32, we can then execute the synthetic division. First bring down the 1. 1 times 4 is 4. If we add straight down, we get negative 9. 4 times negative 9 is negative 36. And then if we add straight down, in this case it's going to be subtraction, we're going to end up having 8, and then 4 times 8 is positive 32, and then when we add straight down, we have a remainder of 0. Therefore, the polynomial can be simplified to be x minus 4 times x squared minus 9x plus 8. And then we can further factor it because there are factors of positive 8 that add up to negative 9, and they are negative 8 and negative 1. So the polynomial, when fully factored, is f of x is equal to x minus 4 times x minus 8 times x minus 1. So now what are the x-intercepts of this graph? Well, we know that the x-intercept corresponds to the opposite sign of our factor. So if we set them equal to 0 and solve, we would get that x is equal to 4, x is equal to 8, and x is equal to 1. Or if we write them in ordered pairs, we have 1, 0, 4, 0, and 8, 0. And now, at which x values does the function value change from negative to positive or from positive to negative? Well, x-intercepts are where the function values are equal to 0. So to the left of them could be negative or positive, and then to the right it would be the opposite. So the x-intercepts are the location where these function values change. And let's make a quick sketch of the graph to reveal this behavior. So if we sketch a graph of f of x is equal to x minus 1 times x minus 4 times x minus 8, we have x-intercepts or zeros of 1, 0, 4, 0, and 8, 0. And then because it is an odd degree polynomial, its end behavior to the left will be approaching negative infinity, and to the right it will be approaching positive infinity. So it'll rise as it approaches positive 1, and then it'll start falling back down as it approaches 4, and then it'll rise back up again as it approaches 8. And we can see that a function has negative values for those x values where the graph lies below the x-axis. So that's going to be for x values that are less than 1, and then from x values between 4 and 8. Written as an inequality, that's from negative infinity is less than x, which is less than 1, or 4 is less than x, which is less than 8. And the way I mentioned it earlier, you can also write it in interval notation. So that would be from negative infinity to positive 1 in union with 4 to 8. And then f has positive x values when it's above the x-axis. So that's going to be from 1 to 4, and then for x values greater than 8. So here's how it's written in inequality notation. And if we were to write it with interval notation, it would be from 1 to 4 in union with 8 to infinity. Therefore, the graph changes from negative to positive at the x-intercept of 1, 0, and then again at the x-intercept from 8 to 0. And then it changes from positive to negative at the x-intercept of 4, 0.